For the first exercise, it says under the same conditions of temperature and pressure, how many times faster will hydrogen diffuse? How many times will hydrogen diffuse faster than carbon dioxide? Okay, so under the same conditions of temperature and pressure, how many times will hydrogen diffuse faster than carbon dioxide? First, we need to identify the two gases. Okay, we have hydrogen and we have carbon dioxide. In other words, you need to know how to write those gases. You need to ask yourself, is hydrogen a diatomic molecule?
Yes.
Yes, remember the mnemonics, okay? Remember the mnemonics, have no fear of ice cold beer, so doesn't matter, okay? If you memorize that, you're gonna know that hydrogen is gonna be diatomic. So, guys, don't mess it up there. There are only 7 diatomic molecules. Please do not forget. Ashley, Xavier, your camera's on, please. So my guesses are hydrogen. I'm gonna write it as H2 because it is a diatomic molecule. And then it says carbon dioxide. Do you remember how to write carbon dioxide? Ashley, your camera. Do you remember how to write carbon dioxide?
CO2.
CO2. Okay, CO2. Okay. So first step that we're gonna be doing is molar masses. For hydrogen, it's going to be 2 times, I hate you so much, 1.0079 grams. I have to work so much when I write all those decimals. And I even know, I already memorized the molecular formula for the atomic hydrogen as 2.0158. For CO2, I have 1 carbon and I have 2 oxygens. Carbon, that is 12.011, and oxygen, I hate you so much, it is 15.999 grams. So you need to get a molar mass of that. You can do it in a single step. You get the same molar mass as me? Well, hopefully you did. Okay, so it says, how many times will hydrogen diffuse faster than carbon dioxide? How many times will hydrogen diffuse faster than carbon dioxide? That means that the gas that I'm going to solve for is hydrogen, okay? So hydrogen is going to be my gas A. And CO2, carbon dioxide, will be my gas B. So I say A over B is equal to the square root of B divided by the square root of A. Remember that this information is crisscross, okay? Okay, A and B. It depends on the question, okay? This question says, how many times will hydrogen diffuse faster than carbon dioxide? How many times? ¿Cuántas veces? Okay, ¿cuánto más rápido? How many times faster? with hydrogen infused than carbon dioxide. ¿Cuántas veces más rápido se va a, bueno, en este caso, esparcir hydrogen con respecto a carbon dioxide? So, in other words, I want to know how faster is hydrogen compared to carbon dioxide. Entonces, the one I want to know is going to come here in the top. So your unknown, put it here in the top. In this case, your unknown is going to be hydrogen. The one you are comparing to is the gas B, that is CO2. Okay? Now, the information here is going to be crisscrossed. Here, the square root of CO2, and below, the square root of H2. Okay, so we say H2 over CO2 is equal to the square root of CO2, that is 44.009 grams, divided by the square root of 2.0158 grams. You can do it in a single step, okay? Square root of 44.009 divided by the square root of 2.0158, and you can give me directly the result. In that way, we're going to work faster. I got 4.67. Did you get the same answer as me?
Yes.
Yes, Miss.
Yes, Miss.
Okay, so because I'm solving for H2, that means that I need to leave H2 alone. In other words, this CO2 that is dividing is going to go to the other side to multiply. Okay? So, this is going to leave you H2 alone, and you say H2 then is going to be equal to 4.67 CO2. How do you understand this? Or how do you analyze this result? In other words, this means hydrogen will move 4.67 times faster than CO2. And then we analyze if it makes sense. Does it make sense that hydrogen moves faster than CO2?
Yes.
If we compare the masses, we conclude that yes, it makes sense, because hydrogen is the lighter gas. The problem is not asking me to find any velocity, it's just telling me how many times faster. Okay? So this is gonna be like the exercise. But if I give you a speed for carbon dioxide, if I say that carbon dioxide moves at a speed of 100, okay, then you can calculate from there, you can calculate the speed of hydrogen. But this is not the case, okay? So that's it. We move on to the next exercise. Well, from this exercise, do you have a doubt? From this exercise, do you have a doubt? Okay. This one says an oxygen molecule travels at about 450 meters per second at room temperature. Find the velocity of a helium atom at the same temperature. So this exercise is slightly different, more similar to the ones that we solved yesterday in the classwork. So we're talking about oxygen molecule as one gas. The other gas that is mentioned is helium, okay? And this exercise is being very specific. It says a helium atom. So when we write the givens, we need to separate our givens, okay? In the two gases that we have oxygen molecule. How do we write an oxygen molecule? Like O, like O2.
O2.
Okay. Oxygen molecule. Oxygen is a diatomic element, which means that those oxygen molecules are going to travel in groups of two atoms, okay? That's what diatomic means. The other is a helium atom. It's being very specific. It is in singular, a helium atom. So it's just one helium. So we're going to focus on getting the molar masses of each. Helium is a very light gas, but not lighter than hydrogen. Okay, helium's mass is 4.0026. So the total molar mass of oxygen molecule is going to be 31.998 grams, and helium is going to be the same because it's just one. Okay, now this oxygen molecule, okay, is traveling at a speed of 450. So we say that this one over here is at a speed of 450 meters per second. What do I need to find? I need to find the velocity of helium. So this velocity is unknown. I need to find it. To find the velocity first, I need to know the rate. So, because I want to find helium. Helium is my unknown. Helium is going to be my gas A. And oxygen is going to be my gas B. So I say A over B is equal to the square root of B divided by the square root of A. Remember that this information is crisscrossed, okay? So A is my unknown, that is helium, and B is my known gas, that is O2. It's equal to the square root of O2 divided by the square root of helium. Okay? So this is equal to the square root of 31.998 grams over the square root of 4.0026 grams. Remember, grams and grams are cancelled. I think I forgot to do that in the example before. I forgot to cancel the units, but they need to be cancelled. Don't forget. How much is this?
2.83.
So we say helium over oxygen. This rate is 2.83 rounded, okay? In other words, helium will spread at a rate of 2.83 the speed of oxygen, okay? So this is the rate. After this, what do I need to do? I need to find the velocity of helium. So I'm going to take I'm going to continue in here, okay? So to find the velocity, I say helium, which is my unknown, then is equal to 2.83 the speed of oxygen. I know that oxygen is traveling at a speed of 450 meters per second. So I will replace oxygen by that speed. Don't forget to write in units, okay? How much you got?
1,188.6.
1,000?
27. No, 1,273.5.
Okay. And these are gonna be meters per second as well. And now you analyze your answer. Does it make sense? Does it make sense that helium is faster than oxygen?
Yes.
Just because
It's lighter.
helium is lighter, okay, it's lighter. About 8 times lighter, okay? So that's why it's a lot faster, sorry. From this exercise, is there a doubt? Okay. Now this next exercise says an unknown gas diffuses 0.25 times as fast as helium. What is the molecular mass of the unknown gas? So in this case, the exercise is different because they are not giving me speed, they are giving me the rate, okay? And they're not asking me for a rate or speed, they're asking me for the molecular mass. So what do I know about the unknown gas? I know that it diffuses 0.25 times as fast as helium. So how do I write this as a ratio, as a rate? Okay, I write it like my unknown gas compared to helium is 0.25. Okay, that's the rate, or 0.25x. Okay, 0.25 times as fast as helium, or you can write it as my unknown gas has a speed of 0.25 helium, but I prefer this one. I prefer this one. Okay, they're asking me what is the molecular mass of the unknown gas. So I don't know the mass of the other gas, so my other gas has unknown molar mass. But I do know the molar mass of helium, that is 4.0026 grams. So these are going to be my given. Remember that the unknown gas, I leave it in the upper part. So I say unknown over helium is equal to 0.25, and this is equal to, now I'm going to write the definition of Graham's law, okay? I'm going to work a little bit more organized. Okay, I'm going to write Graham's law first. This is going to be the square root of helium divided by the square root of my unknown gas. Okay? This is what I know. This is my formula. This is Graham's law. Remember that Graham's law comes from the base formula, that is A over B equals to the square root of B divided by the square root of A. That's the main formula. So all I need to do is I need to adapt the formula. This is already given in the problem. My ratio, okay? My ratio unknown over helium is 0.25. So that's the replacement that I'm going to be doing here. So unknown divided by helium, I know that that rate is 0.25 is equal to the square root of helium divided by the square root of my unknown. I need to isolate for the unknown, okay? And my unknown there is dividing. So I'm going to send it to the other side to multiply. There it is dividing, and in the other side it will be multiplying. Okay? So my square root of the unknown, that is multiplying 0.25, then is equal to the square root of 4.0026 grams. Okay? Now, this 0.25 is multiplying my unknown. That means that I'm going to send it to the other side to divide. So you say the square root of unknown is equal to the square root of 4.0026 grams divided by 0.25. How much is this?
8.
Okay. And remember that those grams are under square root. 8 square root of grams. That's the correct way to do it. Now, to get rid of the square root, because this, okay, this is unknown, but the unknown is under, okay, a square root. So you need to get rid of the square root, you need to apply the power of 2 in the two sides of the equation. So your unknown mass, your unknown molecular mass, is going to be equal to 8 to the second power, or 64. And the square root of g with the 2 is going to be cancelled, so in other words, it's going to give you grams. The molar mass of my unknown gas is 64 grams. Does it make sense that it moves 0.25 as fast as helium? Yes, it makes sense. So you don't know what the gas is, or you know the molecular mass is going to be 64 grams. Do you have a doubt? If you think that putting the square root of g is too confusing, just write the 8. And don't forget, because you are looking for the molar mass, you can write the g at the end. But where does the gram come from? Exactly comes from this. Okay, I'm gonna explain another one of this one. Okay, this exercise is almost the same kind, but I changed a few things, as you notice. An unknown gas diffuses 4 times as fast as argon, a noble gas. What is the molecular mass of the unknown gas? So this unknown gas has a rate of 4 times the speed of argon. And they're asking me to find the molecular mass of the unknown gas. So, given, okay? So I'm going to write this. Unknown gas diffuses 4 times as fast as argon. I'm going to write it as a rate, okay? In what rate? Okay, my unknown gas over my known gas, and that is argon, it is equal to 4. That's the rate, okay? I know the molar mass of argon. Argon is diatomic argon, yes or no?
No.
No, it's not diatomic, so I'm going just to write the molecular mass that appears in the periodic table as 39.948 grams. Okay? So, I say A over B is equal to square root of B over the square root of A. Unknown over argon is equal to the square root of argon divided by the square root of my unknown gas. I know that this rate is equal to 4 according to the given, okay? that rate or that fraction that you see over there is equal to 4. So 4 is equal to the square root of argon divided by the square root of your unknown. So what I'm going to do now is I'm going to isolate directly, and then I will just substitute by the givens, okay? So in here, this one that is dividing is going to go to the other side to multiply. So you will have 4 times the square root of the unknown, then it's going to be equal to the square root of argon. Therefore, this number that is multiplying, then it's going to go to the other side to divide. Square root of my unknown is equal to the square root of argon divided by 4. I'm going to make substitution of the given. I will continue here. Okay, I will continue there. And I just make substitution of the given. The square root of argon, that is 39.948, if I'm not mistaken. Yeah, grams, over 4 is equal to the square root of the unknown. How much is this?
1.58.
1.58. And to get rid of the square root, just raise it to the second power. Remember that this g still remains under the square root. So, can you skip this process? You could, okay? So this will be like getting rid of the square root, leaving just grams alone. 1.58 squared, that is 2.5. So that means that the molecular mass of the gas I'm working with is 2.5 grams. And that's it. Here, this isolation takes a little bit longer, but in the end, the procedure is quite the same. Just remember that to get rid of the square root, all you need to do is raise it to the second power.